In the watershed, you might have some watersheds that, like we talked about before, might have been clear-cut or heavy construction. And the runoff is more severe, the erosion is more severe, and the buildup of sediment in the stream occurs more, producing more turbid water, or the turbidity is high, meaning suspended solids. Well, what we have here is an area that has vegetation on it, and then an area with no vegetation on it. And this is a model that will help your students understand how water running off different surfaces collects and what the characteristics of that water is and how it might impact the stream. So what you're going to do is take a certain amount of water in 2 containers. We have 500 milliliters, which is fine, and 500 milliliters. Or we could put that amount in the spray can and spray it on there like it was rain falling on, or a flooding situation would be like if you just poured the water on. So you can really do it any way you want to. And you can change the variables. The 2 variables we have now, and that is vegetation, no vegetation. But other things you can do is maybe to change the incline, whether it's a steep incline or different levels of the incline, the amount of water that you put it on, and the time that you put it on, or the force that you put it on. So in this activity, it's really observations, and what you do is you let the students create their own investigation where they want to decide what they want to examine. So it's kind of an open-ended investigation rather than have you do kind of a cookbook thing, step 1, 2, 3. You see what I mean? So it's more kind of inquiry-based. What did you notice about the water from the vegetated area as compared to the water that was, I guess we could describe as no vegetation or clear-cut model?
The clear-cut model had more sediment in it, and the one with the vegetation, it was very little.
Okay, well the sediment builds up in the stream. It runs off when you don't have vegetation. It builds up in the stream, and that's what we refer to as turbidity. And when a water is called turbid, it's murky, that's a good word to describe it. How does turbidity, and this can be anybody, affect the animals and plants in a stream?
Well, the more turbid the water, the more sediment. So the more trash, the less, it's going to make it difficult for the fish to breathe.
Well, how does it impact the fish?
It would affect what grows in the stream, wouldn't it? I mean, if sunlight can get down through the water, wouldn't that affect the vegetation in the water?
Yes, and the fish eat vegetation. So, and I think that, Coley, you mentioned earlier about the gills of the fish. The sediment actually gets deposited in the gills of the fish.
And the salmon, I believe, when they lay their eggs, they need a rocky creek bed. But when it's silted over, there's no way that they're going to lay their eggs. So it's also a question of the next generation, not just of getting enough oxygen.
And also sometimes when they do lay their eggs, the sediment covers up the eggs and prevents them from even being hatched or matured. And so also the sediment, like you were mentioning, Richard, interferes with the light penetration, and so plants aren't able to grow. Also, I think the third thing that I didn't realize until I was researching it is it increases the temperature of the water. And when water increases in temperature, dissolved oxygen decreases. So it affects the dissolved oxygen in serious ways, which also affects the life of plants and animals in the water. So this next activity, we're going to look at turbidity. And to do that, we just have a jar with clear water. We put a piece of black construction paper around the glass jar with the water, and there are holes in this side and this side that were punched at the same time and taped exactly opposite. So we fit that over the jar. And then we're going to hold up the jar, and about 5 inches away, we're going to hold a piece of black construction paper, so if you could hold that, and shine a flashlight through the jar. And as you can see the holes reflecting, the light passing through the holes and being reflected. Well, the water's clear, as we saw. Well, what happens when we add sediment? And that's the purpose of this experiment. So what you're going to do is add measured amounts of sediment, stir the sediment, same amount of time, put back the construction paper, and shine the light through to the black construction paper. And just make observations about how much sediment do you add before the light does not penetrate. Now I can't see any light. How many teaspoons did you add before the light was not able to pass through?
About 3, yes.